Our next topic is sparse matrix. A matrix in which there are more number of zero elements are there. I have an example matrix of order 8 by 9, and you can see that it is having very few non-zero elements like 3, 8, 10 and 4, 2, 6, 5, 9. There are very few non-zero elements. If I count 1, 2, 3, 4, 5, 6, 7, 8, only 8 non-zero elements are there. Mostly in statistical data or survey data, data may be represented in the form of a matrix and there may be a lot of zero values. If so, then if we are using sparse matrices in our program, then we may be having a lot of zero values for which we may be wasting space and also processing time. So again, the same thing, we want to store a matrix in less amount of space and the processing is also less. So what we should do? We should store only non-zero elements. So for storing non-zero elements, there are more than one approach available. One method is coordinate list and the second one is compressed sparse row. So these are two representation, coordinate list and compressed sparse row. And this coordinate list is also called as 3-column representation. So first we will see coordinate list or 3-column representation. For coordinate list, for every non-zero element, we need 3 things. First is its row number, second is column number and the element itself. So for 3, row number is 1, column number is 8 and the element is 3. For 8, this one, row number is 2, column number is 3 and the element is 8. So we will have a tuple of 3 values, that is row number, column number and the element. So we can have the list of tuples, so we can call them as coordinates, or we can represent them in the form of columns, that is 3 columns. First column is row and the second column is column number and the third one is element itself. Now let us represent those non-zero values in these 3 columns. So first non-zero value is 1, 8, 1, 8 and 3. I have left the first row blank, so at the end I will show you what is the use of that first row. Then 8, 2, 3, 8, 2, 6, 10. Then 8, row number is 2, column number is 3, element is 8. So 2, 3 and 8. Likewise, I will fill up all those non-zero elements. So here I have filled 3 columns with row number, column number of each element and the element itself. Now in this one, first row I left it as empty, that I can use it for storing information about the sparse matrix. So about the sparse matrix means what are its dimensions? 8 rows and 9 columns. 8 rows, 9 columns. Then how many non-zero elements are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 non-zero elements are there. So first row we can use it for number of rows and then number of columns and number of non-zero elements. So this is a commonly used method. Using this method, I will show you how to perform addition and subtraction of matrices. But before that, let us look at the second method, that is compressed sparse rows. Now second method, compressed sparse row. In this method, a sparse matrix represented using 3 arrays. So the first array is list of non-zero elements. I will write down non-zero elements. 3, 8, 10, 4, 2, 6, 9 and 5. So this is a list of non-zero elements. I have taken all those non-zero elements in the same order in which they are appearing. Don't change the order, like first 8 then 10. Don't change the order 10 and 8. Next, we need an array for rows. So this is important one, just watch it carefully. So we will have an array of rows. In this, the very first thing is 0. The very first value is 0. So initial value is 0. Our indices are starting from 1 onward. So this is for 0th index. 0th index. Then next, in first row, how many elements are there? 1 element is there. First row. This is for row number. Then in second row, how many elements are there? Second row, 2 elements are there. Then plus 1, that one also. So we'll write 3 here. So this 3 is nothing but 2 elements in the next row plus 1. So this will take the cumulative of number of elements. Initially there is 0. Then first row having 1 element. Then till second row, total 3 elements are there. Then in third row there are no elements, so it should be 0, but this previous number we will take it. So this shows that 3 minus 3 there are 0 elements here. 3 minus 1 there are 2 elements here. So we'll take the cumulative of the number of elements for each row. Even I will write down the indices for row number. This is for 0th row, there is no 0th row. This is first row, this is second row, and this is third row. Then in the fourth row there is 1 element, so it is 4, one more. In this 3 plus 1, that is 4. So this is for fourth row. Then fifth row there are no elements, so let it be 4 only. Then sixth row there is 1 element, so this will be 5. Then seventh row there is 1 element, then it will be 6. Eighth row there are 2 elements, then this will be 8. So this is for fourth row, fifth, sixth, seventh, and 8th. So for every row will contain the number of its own elements plus the value in the previous row. Then the third one is column array for j values. So this is JA. Now this element is present in 8th column. This is corresponding to the element. This is in 8th column. Then this is in third column. This 10 is in 6th column. 6. For every element we will have a column number. This is in first column, and 2, this is in third column. Then 6 is in fourth column. Then 9 is in second column. Then 5 is in fifth column. So as many elements are there, that many columns are there. But here as many rows are there plus 1 because it starts from 0 onwards. So this is another method that is called as compressed sparse row. Let us analyze this little bit upon space. This is a sparse matrix of 8 cross 9. Total 72 elements including zeros, that is zeros and non-zero. Together there are 72 elements. And if each element is an integer and is taking 2 bytes, so this is 144 bytes. So if we focus on the number of elements, that is sufficient. But here, how much space is required? 8 non-zero elements. Then this one, 8 non-zero elements. Then what about this one? Total 8 rows are there plus 1, so this is 9. So this depends on number of rows, and this too depends on number of non-zero elements. So total how many elements are there? 25 elements are there. Then if all these are integers, then require into 2 50 bytes of memory. So that is 144 and this is 50. So almost it is 30% of that space. So 30% of memory is reduced if you are following this method. So similarly in the coordinate list or the 3-column method also the memory is saved. Now I will take 2 small examples of sparse matrix and show you how addition of sparse matrix can be done.